Good day, hi there, and welcome to the presentation of my senior research project, developing a mobile application as a learning platform for an engineering mechanics course. I'm Thomas Carstens, and I developed an app for a mechanics course in my final year of undergrad in mechanical and mechatronics engineering. I proposed this project to Bruce Clute, who acted as supervisor and lecturer in the same course. This is a course he lectures in the first and second installment in the first semester and the second semester of the year. And so I was able to come in. What I proposed is to develop a novel learning platform for MEC 2023. The purpose of this was to aid the students in their learning. This is quite broad, and so a series of steps needed to be implemented to refine this. Essentially, I came in to understand the learning strategy in the course, decided to generate concepts and trial them in the first installment, and once the concept was selected, implement the final platform in the second installment of the course as a fully fledged mobile app. So this research project was ethically approved by the Mechanical Engineering Ethics Committee. Alright, so this presentation will be done in two steps. The first, the integration into MEC 2023, will expose the features of the application, if it was used, and what software was used for this application. And the second step will show the measures that were used to implement the application in the course, the research procedure, and further measures for implementation. So MEC 2023, otherwise called Dynamics 1, is a second-year mechanics course, part of the undergrad curriculum. Both mechanical engineers and mechatronic engineers take it. There are two broad topics. One is kinematics and the other one is kinetics. Kinematics examines motion and relating to displacement, velocity, acceleration, and so on, motion of point masses. And kinetics looks at the motion of bodies, and so brings in the cause of such motion, whether it be a force or a torque. Yeah. So this is a concept-based course where the lecturer shows principles and gives exercises for the students in the form of tutorials and other exercises. So there's a lot of application. So before I show you the application itself, let me show you if it was used in the first place. So just two graphs to expose this. The first one showed the amount of awareness of the application. So students were aware that they could use it free of charge, the vast majority of them. And the second graph I'll show you relates to day-to-day use. So the green line on the bottom shows use in the last 24 hours relating to the time of capture. The purple line looks at the last week before time of capture, and the green line looks at the last month. The top lines incorporate user retention or illustrate it in a better way than the first bottom line. But essentially, there was definitely a constant use of the app, which is well reflected in the top lines. and shows how the use spiked between the tests. All right. The purpose of the application is for students to post any education-related content and for tutors to be notified automatically. This means that the students can contact the tutors remotely and at odd hours. Now, some context about the course. Since it's a concept-based course, there are quite a few exercises the students are required to do in their free time out of lectures, and while there are some exercises in the tutorials, there are more in their own time. The course philosophy is to only supply the answer to a problem and not the method. So students who have the wrong answer might not know what the right method was. And by contacting the tutors remotely, they can ask very general questions to very precise ones. So the feature set for that requires a social media feed layout, much like Facebook. And so students log in, can browse through posts, can comment on them, can create their own, they can edit their own posts. The push notifications are meant to ensure the student knows if someone interacts with their post, and the tutor knows when the student replies. And so there are certain roles built into the application and further features to engage the course community. The first view is the login logout, where students access the app with their UTT email and a custom password. The password is HTTPS encrypted, and the email, being a UCT email, is quite an interesting feature, as this is the entire initiative is meant to be separate from the university's learning management platform, VULA. But by using your UCT email, you definitely can identify yourself as unique, and we can make sure that you're a part of the community, essentially. If you don't have an account, you can sign up through this view, and you can go through a password reset process. And more generally, when the application is on your phone, you only have to enter your details once, and further times you'll be logged in automatically. So upon authentication, you enter the social media feed, where you can browse other user posts. Each post has a query, and sometimes has a picture. And if you look at the central one here, the top line has the word resolved. That says that the tutor has effectively helped the student, and there is on that top line also the word student, which means that the student does not want to be identified by name. And then below the query you see uncategorized. So this work hasn't been put into a category, but it can be put into a category. More about that later. And you see the number of comments and the time since post. So quite a few details. If you look at the picture in the one view and you click on it, you can zoom in on it. Open it up in Zoom, and you can even share it. So the idea is that this is not the only means of communicating online, and so students can share it with other social media. If you click on the comments button, you can see the comments for each post. This is a modal view, so it pops up for any post, and you can see all the posts. all the comments. As you can see, the hopeful student, identified as a hopeful student for the sake of anonymity, has posted 3 comments, and the student who posted, who is also anonymous, has thanked the hopeful student. So it's very straightforward in that sense. You can also put pictures in your comments and so on. To create your own post, you can type out your post from the main feed. You can use photos from the camera or from your image library, crop pictures if you need so, and type out a query. The query itself can include formulas and equations. The formatting is done through KTech, so there's a particular way for formatting it into the app. So there's a little guide there. That's a link to a website. It's not actually part of the app. If you post, it confirms with you, just to make sure some people don't just accidentally post something, and it checks if you want to remain anonymous, and then you post. This person chose to remain anonymous because they are referred to as student. And there is also a direct feedback option, but more about that later. Once you've posted your content, you can edit it. To do so, you go into the post options, and it opens a configuration layer. And this means you can edit text and edit the picture, and also add the relevant section of work this goes in. Now, the section of work adds another layer of searchability to the application, because different work can be categorized. A quite important part of the application is the push notifications, whereas tutors get notified when a student posts or when anyone posts. This is one layer of the notifications. Then there is another when the student who posted gets notified when someone comments on their post. The person who commented on the post gets notified if their comment receives a response. And that same tutor is now in the loop, and the other tutors don't necessarily receive notifications all the time. So upon clicking the notification itself, you enter the app. 2 different roles are configured for all the users on the database. Either you're an educator, named as a tutor role, or you're in the student role. So these configure different permissions for you. The student by default will not receive notifications of new posts unless they configure that as if they want to receive, for some reason, know of new posts. But the student cannot delete other students' posts. They can only delete their own, and they can not edit other people's posts. They can only edit their own. They cannot resolve other people's posts. They can resolve their own. The tutor has all these abilities, though. Yeah. There are further features for engagement to enhance engagement. The one is personalized notifications that explain exactly what happened, not just someone replied, but X replied, or X said this, X commented on, so on. As you can see, all the things around the query, around the post, are meant to enhance engagement, like the fact that a post is resolved or not resolved, as all the unresolved posts go above the resolved ones to prioritize them, and so on. The number of comments is shown to in real time, and the amount of time since the posts changes in real time. The comment section is designed in a very colorful manner, and once you enter the comment section, it slides down to the last comment, so there's a smooth interface, and it hopefully enhances engagement. The technical requirements for the application are going to explain the process taken to develop it. This application it's a native mobile app. It's cross-platform, so it's for Android and iPhone users. And it is serviced through Google Play and on the iStore, specifically on test flights for beta testing. And it was no longer serviced. This happened. It was serviced between October and September 2018 during the time of this project. So as the graph shows, there were two major platforms for smartphones: Android and iPhone. This made it very enticing for students for a online learning platform developer like myself to create a smartphone-based application where students are in contact at all times. But to cater to both these platforms, I decided to do something cross-platform, only to speed up the process of development. And because push notifications were quite important, at the time only native applications could do so. So this sets up the field of play. A native app would have to be created through Ionic 3 at the time, and that meant that it had to be packaged for Android and for iOS. So here is all the software that I used, starting from Angular, the code, Ionic 3, not 2, and packaged as a web page with plugins, and serviced to iOS and Android. The development environment was a little larger, where I used Atom and packaged to Xcode that could only be used on Macs and Android Studio. The database requirements were quite interesting, so I used Firebase. It's a database provided by Google, and what's interesting is it's used for development, but it was an ideal database for a small group of users. The course I was in, the Dynamics 1 course, it had 178 students, 7 tutors, 2 lecturers, and myself. That makes under 190 individuals, and so cloud messaging was possible. Cloud functions and real-time functions were possible. Real-time functions meant that comments appeared and posts appeared in real time. Comment counts appeared in real time. I was able to authenticate and store images and create analytics that I could use later, like the graph you saw earlier. Now, in order to replicate this application again, the web app and the database can be designed again for up to 500 users at any one time, and this means that there's a period of development that I think is quite useful. Depending on your technical requirements, obviously I've extended it to a month and a half, but if I were to do exactly what I did here, I think I could reduce it to 20 days. So yeah. Now I move on to the second stage of the presentation. That shows how I implemented the project into the course. It's less concerned with technical and more so with implementational. The very design of the application taken into account, as I understood or took a departure point in understanding the learning strategies and generated concepts which are trialed. I chose a concept, developed it into a mobile app, and in implementing that mobile app, certain measures were taken. So the first one is to generate concepts. The first stage is to ensure certain measures for the optimum functioning of the app. Third one is in implementing it, promoting it, and organizing the course educators. Then, in order to improve the app, I sought feedback in the form of Google surveys, Google Forms surveys, and then a version. In the first stage, I needed to ensure my concepts were aligned with the learning strategy of the course. In fact, Bruce Clute wrote a departmental report on the state of Dynamics 1. It's a report from 2010, but it exposes his strategy and the strategy that was adopted as soon as he took the course. It goes along 3 lines. If I am to simplify it, the first line is exercise centered conversation. An effort needs to be made to frame the content in the context of discouraging students from trying to solve problems with simple algorithms. The second one is about content clarification. There are a number of creative possibilities for helping students visualize dynamics problems in the apparatus. And the third one is to vary the approach, vary the method, as I prefer to call it. The trial platform was actually a Google Drive repository, and fortunately for me, I was able to link the course tab on Vola directly to each document, and each document students intuitively understood that you can highlight a part of the document and comment on it. So the trials took in this Google Drive layout. As you can see, here's the Vola learning management platform, and you can click on any of the links. In the first stage, we made it possible for students to comment on the tutorials. Tutorials happen once a week for 14 tutorials in total. And so I could access the Vola analytics of how many times people clicked on the link to the repository, and I saw that it did in fact spike. It was quite sustainable throughout the period, but it spiked through in the period of the tests. Then we let the students comment on the test and memorandum that was released minutes after the test. And obviously there were huge spikes, but especially after the second and the third test. But in between there was little to no activity on the memorandum, and this was not very encouraging as an initiative. And finally, the students were given the chance to upload their own solutions of problems onto a repository and ask for lecturer guidance. This looked like that. Students were able to upload their own work and ask questions. The analytics does not say much because this was implemented close to the end of the trial period, but it was in fact one of the most interesting of the 3 initiatives, mostly because it was most aligned with the learning strategy. If you think back to exercise-centered conversation, content clarification, and methods clarification, it is, after all, the students' exercise that we're looking at, where tutors can clarify content in a variety of options that had to be developed later, pictures and so on, and text and equations. And as for the method, students could expose their method and see where they went wrong. Now, safety measures were required in order to make sure that this was implemented in a safe way. I will quickly go through all three. The first concerns data that englobes user identity and history. So among themselves, students are anonymous, and so they can choose to remain anonymous, or they can give themselves a name, a profile name. However, between students and us, there is their verification with UCT emails, so they are known entities and not completely unknown. Their history is obviously logged onto the database. Accessing that history will be talked about later, because essentially when it comes to personal and sensitive user data, there are a few measures. The first, file-based authentication, allows passwords to be encrypted, so even I can't access their account. There are security rules when it comes to databasing. There are cloud identity and access management rules when it comes to everything else, like image storage, analytics, and so on. I have a non-disclosure agreement for the sake of professional conduct, not to disclose any content that I found on the database. And there's a privacy policy that's offered to the students to understand the use of the data for my uses. When it comes to objectionable content, or content that's not in the interest of education, in our case, the approach was reactive. So the idea was to create a WhatsApp group between tutors, lecturers, and researcher, where any issue on the app would be logged onto the WhatsApp group. There were no issues. The group was mostly used to ensure that students were replied to, and there was a reactive approach, essentially an approach to wait for non-educational content to appear before we would make a decision as to delete it or so on. I think that was the best approach when it comes to an experimental project like ours. The setting up of the application or implementation took a number of stages. Here you can see an advert that says exactly how you can access the application. The first thing to do was to organize the tutors so they could reply, all 7 of them, as soon as they could. They were all paid in advance, and the idea was to be able to help out where they could. The app was promoted to the students in the form of this advert on the front page of their Vula. And upon implementation, there were certain issues. So the camera broke down on iPhones specifically. It was difficult to figure out why. Login was not automatic, so people had to enter their details every time, and that we lost a lot of users that way. And so smoothing that up was quite important, and adding a password reset option. A user needed expansion of the text box. When he posted, he couldn't move back and forth on his own text, so he couldn't edit it. That was implemented using a plugin. When it came to versioning the app, and that is to iterate it to improve the app, the problem that realized was that people would be on different versions. And so, because this was a small community and a small initiative, I decided to block any users who had older versions of the app by logging them out and giving them a page that said, please update to the most recent release. This was a simple way of keeping everyone up to date. Now, when it came to seeking feedback from the students, I did do a survey using Google Forms where I asked for general feedback, the type of phone owned, as you saw, awareness of purpose, as you saw, awareness of availability. So it's an app that's freely available. Student download coverage was quite interesting to see if most of the students use the app, and so it was quite interesting to see that of the 178 students there were about 100 who downloaded the app and only 50 who used it more or less regularly, at least once a week. So then there were more subjective questions. I'll look at some of them now. The way I tried to post these questions first was through direct feedback when you post. That did not work very effectively. So the survey option was integrated into the application where you consent to the survey and then you do it. Once I had all the survey responses, I chose to qualitatively process them. And that meant, in my case, to take each response individually and organize them on Trello along themes, particular themes, as you can see here, and as you will see in the next slides. The two main themes are, for my own understanding of the project, students mentioned methods for collaborative learning and different methods, and then they mentioned means of better user control over their own content. So generally, this was an interesting finding that half the users that were surveyed, so 107 of the 180 students filled out the survey, and half of them, so 50 or so, browsed through posts. Here are some reservations that expose limitations of the application. So a third of the students prefer to ask their friends for help and would rather ask tutors in tutorials. And as you can see, others haven't really had the option of using the application, but they say they would if they could. An interesting finding when it came to time slots. So most of the students were interested in tutors being on the app at a very specific time, but it was quite difficult to piece out this evidence because although it's a positive or negative, some students were very neutral about this and thought it was a good general idea. Some of them were opinionated because it benefited or did not benefit the students, or opinionated because it benefited or didn't benefit the tutors. So quite a lot of responses on this side. When it came to tutor-student engagement, here's quite a broad question. How do you feel about the engagement? The two top options were quite neutral. Students obviously would preferably share answers rather than keep them, and that the tutors, more tutors rather than less, should answer. But then student answers to the post should be reviewed by tutors suggested that students worried that other students didn't know the right answer. And then the fifth option, the lecturer should review tutor answers, is quite an interesting finding. The fourth option, the first tutor to reply should take charge of follow-up comments, is quite neutral in itself, and so on. These small, the top starred options are user-entered options, and so those are possible avenues. What was explored in order to enhance the app from this was the notifications, enhancing it by adding different functionality to the notifications. Here's another general question: would you worry about these? And with 3 user-entered options, but that does not fall into the other themes. But there's a lot of worry about students or tutors giving the wrong answer. Students who know my identity might judge me for my work. That's the 3rd option, and that suggested that anonymity was required. So a majority of students wish to be anonymous, but a lot of students said, I don't mind if tutors know who I am when I post or when I reply to someone's post, and much less said that they wanted students to know who they are. In context, I interpreted this as something very specific to second-year engineers who are worried about looking stupid in a course where mistakes are definitely common. So that's the way I tend to look at it, and so anonymity became an option, especially when it came to the design of the feed. The students had the opportunity to give me features to develop, and you can see a user-entered feature, which is making a voice note. That was not configured in the time of the project. The top options were configured into the application. Nice formatting of equations, as you saw, happened through KTech integration. Uploading the image from the phone and saving picture to my images was also made possible. The faster tutor response hopefully happened due to the additions to notifications. And choosing to post to a select group of users did not happen, and adding a website and did not happen, but options of putting GIFs and links and posting to specific people are avenues that we can definitely explore, as well as making a voice note, which would be a different option for collaborative learning. Just as a side note, that would probably be easier to describe an equation than timing out a fully fledged formula. So when it came to replicating the app in other courses, an interest in finding from the students that can show the application's limitations is that students struggle to see the application work in terms of catering exactly to engineering mechanics. So while certain things were implemented into the app, the use of vector diagrams, which is very frequent in engineering mechanics, and other visual aids are difficult to implement in a picture basis application. Although you can take a picture of such things, honing down on exact details is a lot more uncomfortable, let's say. And so further areas for exploration need to take in these limitations. And I wanted to thank on this presentation and for the course of this entire project that happened from February to October 2018. I wanted to first thank Bruce Clute for supervising a project of this scale and this unique quality. Ulrich Rivet allowed me to use her Google Play and iStore accounts, which require substantial amount of investment. So it was great that someone from UCT could help me. Daniel Mesham and Given Chuma, they lent me their Apple devices. As you know, to upload to the iStore, it must be done through a Mac. I do not have the equipment. Marco, John, Conrad, and people in CodeReg helped get me up and starting app development, as it's not something that I necessarily worked in mechatronics engineering, and many more for allowing me to test this proof of concept. And finally, here is a summary of the project and my contact details if you wish to contact me. Thank you very much, and goodbye.